Okay, to continue with the rectangle class, we have completed declaring our instance variables. We completed coding our constructors. We completed coding all of our set methods, and we've completed coding our get methods. We've got 3 left. I'm going to do this in 2 parts. So the next set are the calculation methods. I'm going to go ahead and add a comment here. Various other methods. Like I said, that's just a flag basically to help me keep track of where I am in my code. Our UML told us that we're talking about a public method. We're going to do calc area first. The UML specified that we need to return a double value, so we code that. We're not going to declare this as final. We might have subclasses or some reason to tweak the formula in another area, so we're not going to do that. But we are going to make sure we clearly define the type that's going to be returned. And we are going to stay with the precise name that the UML gave us. We're not going to alter that anyway. The UML specified that there were no input parameters or arguments, so that's simply an empty set of parentheses there. Now I'm going to do this in a very, very granular step-by-step, little baby step-by-step mode. This is just to make sure that we all see all of the little pieces that are involved in what we're doing. So I'm going to declare an area, a variable called area, and declare it as a double. There are a couple of ways we can do this. I'm actually going to do the longest possible. I'm going to declare another area, another variable. I'm sorry. I'm going to call this double, and I'm going to call it rectangle width. Yes, I know that's long. Just work with me on this one for a moment. And a third double variable called rectangle length. Okay. Again, this is very, very, very granular. And we'll talk about the granularity, the level of detail, when we get done with this particular method. I am going to set rectangle width equal to, now remember, we cannot access length or width directly. Those are the instance variables. We cannot touch them directly. That is not permitted. So what I'm going to do instead is I'm going to use that local variable I declared as rectangle width. I'm going to set that equal to the return from calling get width. That gives me a local copy, local specifically to this method. Its existence, its scope is limited to this method. I'm going to repeat essentially that process for length. And then because I have to, I'm going to line those up. Now that's going to give us local copies of those two values when they're spelled correctly. Excuse me. That are local to this method only. Now I'm going to set area equal to rectangle width times rectangle length. Okay, that is our standard formula for the area of a parallelogram, basically. So we're going to do the calculation, and then finally we're going to return the results of our calculation. Now this is a very, very detailed, very granular, very fine approach to doing what we need to do. This is great. This is beautiful. It's functional. There's nothing at all wrong with this. It will take a fraction of a second longer to compile than another version. It may take a tiny, tiny fraction of a second longer to execute than another way to write the code. But I want to reiterate, this is great. It does what needs to be done, and it gets the right answer, and that's the important part. I tend to write code in a much shorter version, a much shorter fashion. We refer to that as dense code. What I'm going to show you isn't incredibly dense code, but I do want to show you a different approach. Neither is the right approach. They're both correct. Okay? I can't stress that strongly enough. It is not this or that based on correctness or accuracy or anything like that. It's this way or that way based on what you like, what you're comfortable with, how you prefer to code. Okay? I just like to show you a couple of different approaches to things where I can. So we have another method. It is also public, not final, just in case we need to tweak later legitimately. It also returns a double, and this time it's calc perimeter. It receives no parameters. That's an empty argument list. Okay. Now instead of 2, 3, 4, 5, 6, 7 statements, we're actually going to accomplish this in a single statement. What's happening, the actual steps being taken internally by the computer when the statement is executed, will be very, very similar to what we did in calc area. We'll have a storage place set aside for us. We will recover and store, or retrieve actually, and store copies of those two instance variable values. Then we'll do the calculation and we'll return the results of the calculation. But we can do that with a single statement. You can do it either way. I like to show you a combination of approaches where I can. So this actually starts with the word return. And what we're going to return, I am kind of a math geek. I love my parentheses. So I'm going to start with that. Actually, I'll just do that. Sometimes it's better to do the parentheses open and close to define scope. It works well. So the formula we were given was 2 times, and in parentheses, add the width to the length. So I'm going to start with my 2 and my multiplication. I'm going to open another set of parentheses in this. Remember, we cannot touch those values directly. So what I'm going to do is call getWidth to retrieve that value, and then I'm going to add length. But to get to length, I'm going to call the getLength method. Okay. I want to walk you through the actual order of what's being done here. We're going to execute getWidth. That brings us back a double value. It's stored in a register in an unnamed location, but it's stored and the JVM is keeping track of it. We are then going to call the getLength method. We're going to retrieve a copy of that double. It is stored in an unnamed location that the JVM, the heap, is tracking. We're going to add those two things together. The result, again, stored in a local unnamed location. We're going to take that sum and then we're going to multiply that sum by 2. That's going to give us our final result. Again, stored for us. We just didn't have to give it a name. And the result of that whole calculation there is then sent via the return statement to the caller of Calc Perimeter. Again, I want to reemphasize, there is no right or wrong between these two approaches. There is no right or wrong. There is a, what are you more comfortable with? How do you prefer to code? There is no right or wrong. When I ask you to code things, basically I'm saying, here are all the things you need, and this is what I need you to do. How you get from that point A I provide you to the point B I need you to get at, the route you take, is entirely up to you, provided you get to the right place, the right end solution, and you get there when I need you to get there. How you do that is going to be entirely up to you. There's a lot of interesting ways to code things. I can tell you from experience that anything you want to code, there are at least 3 ways to do it, and I can normally rattle about 3 ways off the top of my head to do a thing. If you give somebody a little more time, especially someone with experience, they can give you 3 or 6 or 12 other additional ways to do a thing. Unless your designer has told you, or I tell you, you must use this method, any method that provides the correct results is the right one. Okay? Thank you.